Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem number 13, fluid mechanics. Okay. As usual, first we come towards statement. Estimate the pressure needed to raise a column of water to the same height as a 35-meter tall oak tree. Okay, we have to determine pressure. Okay, dear students, here the term oak is not relevant to our problem. Okay, our problem is to find out the pressure rather than to know the nature of tree. Okay, we can easily google this term from here. Okay, but it is not our primary concern. It does not make any difference whether oak tree produces mangoes or oak tree produces oranges. Okay, so it is just a tree. Okay, whatever may be the nature of this tree. Okay, we will not go towards meaning of oak. Okay, irrespective of whether this tree produces mango or this tree produces orange or it does not produce anything. Okay, so dear students, here height is given as 35 meter. Moreover, a column of water means we have to bring into consideration density of water, which is 1000 kilometer per kg per meter cube. Okay, so let us come towards our solution in a regular manner. Dear students, starting portion of our solution will be quite similar as in previous modules of fluid mechanics. Okay, so density is mass per unit volume. If a mass m of homogeneous material has volume V, then its density rho is given by rho equal to m over V. Okay, mass per unit volume. This is equation number 1. Okay, we have given equation number 1 to this expression. Moreover, we know from table of densities that density of water is 1000 kilogram per meter cube. Okay, we can also write it in this form, we can also write it in this form. Okay, in this module we will also show table of densities. Okay, just as a formality. It is not very much necessary. Okay, now we come towards the next portion of our solution. Okay, we know that the pressure at a depth h in a liquid of constant density rho is given by P equal to rho GH, where P denotes pressure, rho denotes density, G denotes acceleration due to gravity, and H denotes height, where G is the acceleration due to gravity. Okay, it is a constant, and we know from our early classes that its value is 9.8 meter per second square. Okay, now dear students, in the next part of this solution, within bracket some explanation is given which will make our concept more clear. Okay, these three dots indicate because or since. Okay, because pressure is equal to force over area, and according to Newton's second law, F is equal to mg. Okay, so pressure has become equal to mg over A. Now this has become equal to rho into volume into g over A. Okay, we have not disturbed g over A, we have only replaced m with rho v, because we know that density is equal to mass per unit volume, m over v. Okay, equation number 1 this. From here m is equal to rho into v. Okay, m equal to rho into v. Rho is equal to m over v. Rho equal to m over v. Here we have not disturbed g over A. We have simply put the value of m equal to rho into volume, m equal to rho into volume. When we will keep m on one side, then it will be multiplied, volume will be multiplied with rho, and m will become equal to rho into v. So here rho equal m equal to rho into v. G over A, rho into v. Yes, rho into v. In place of v we have, in place of m we have used rho into v. Okay, dear students, we know that volume is equal to length into height into width. Okay, it is three-dimensional. Okay, volume is three-dimensional, length into height into width, while area is two-dimensional. Okay, so we can write volume equal to area into height. Okay, we can say that if volume is equal to length into width into height, then area will be length into width. Okay, so from here area will be cancelled out with area, and P will become equal to rho Hg. Okay, rho Hg or rho Gh, same thing. Okay, we have only changed order, nothing else. Okay, so within this bracket it is explained how pressure has been written in this form, that pressure is equal to rho into G into H. Okay, dear students, now using equation number 2 we can find out our solution quite easily, because density is given in the table of densities. Density of water is 1000 kilogram per meter cube. Acceleration due to gravity g has value 9.8 meter per second square, and h height is given in the statement, which is 35 meter. So putting these values using rho equal to 1000 kilometer per meter cube, g equal to 9.8 meter per second square, h equal to 35 meter, in equation 2 we have P equal to, okay, we do not repeat, we do not discuss this. Okay, pressure has become approximately equal to 3.4 atm. Okay, atmosphere or atmospheric pressure. Okay, actually, dear students, we have done nothing. We have put these three values in equation 2. Okay, in place of rho 1000 kg per meter cube, in place of g 9.8 meter per second square, and in place of h 38 meter. And after simplification, this m square will be cancelled out with will be subtracted from m3, and simple m will remain. Okay, so it will become 343,000 kg per meter second square. Okay, and we know that this term is equal to Newton per meter square. Okay, because Newton is equal to meter kilogram per second square. Okay, so this term has become equal to Newton per meter square, and we also know that Newton per meter square is equal to Pascal, denoted by PA. Okay, so pressure has become equal to 343,000 Pascal, and this figure can also be written in this form. Okay, because it can be written as 343 into 10 raised to the power 3, or 34.3 into 10 raised to the power 4, or 3.43 into 10 raised to the power 5 Pascal. And this is approximately equal to 3.4 atm, because 1 atm atmospheric pressure is equal to about 1.103 into 10 raised to the power 5 Pascal. Okay, for this we will show table in the next step of our solution. Okay, so our problem has been solved 100%, and estimated pressure has become approximately equal to 3.4 atm. Okay, atmospheric pressure. Now, dear students, this is the table of densities which we have shown many times in our previous modules, and here once again as a formality it is being shown here. This thing, water, 1.00 into 10 raised to the power 3 kilogram per meter cube has been used. Next table is conversion factor between different units of pressure. Okay, 1 atm, 1 atmospheric pressure, is equal to 1.013 into 10 raised to the power 5 Newton per meter square, is equal to this into Pascal. This alternatively become equal to 101.3 kilopascal. Okay, 1 atm is equal to 1.00 into 10 raised to the power 5 Newton per meter square, same written here. Okay, so this thing has been used in our above portion. Next, this table is also has also been used in our solution. 1 Pascal is equal to 1 Newton over meter square, equal to 1.450 into 10 raised to the power minus 4 pound per inch square. Okay, equal to 0.0209 pound per feet square. 1 bar equal to 10 raised to the power 5 Pascal. 1 pound over inch square equal to 6895 Pascal. 1 pound over foot square equal to 47.88 Pascal. 1 atm atmosphere or atmospheric pressure equal to 1.013 into 10 raised to the power 5 Pascal, equal to 1.013 bar, equal to 14.7 pound per inch square, equal to 2117 pound per feet square. 1 mm millimeter of mercury, Hg stands for mercury, equal to 1 torr, TORR torr, equal to 133.3 Pascal. Okay, these three tables were just shown for assistance, for guidance. Okay, our problem had already been solved 100%. Okay, now we come towards the reference book from where this problem has been chosen. Okay, our reference book is Physics for Scientists and Engineers with Modern Physics. Author is Douglas C. Giancoli, publisher is Pearson. Its fourth edition 2009 has been adopted or followed, and here chapter number 3 under title Fluids is our concerned chapter, and this problem is enumerated at serial number 8 of the exercise of this chapter, that is exercise number 13.8, and this is the end of our module. Okay.